Welcome to the project demonstration of dual axis solar tracker. So in this project we are going to track the sun to get the more power from the solar panel by using the two DC motors and 4 LDR sensors. So whenever the sun is moving east to west, then these two LDR sensors to detect the sun position and place the solar panel always perpendicular to the sunlight, means always facing towards the sun. So for that we are making use of this DC motor, and whenever due to the winter season the sun deviates towards the south side, and that will be maintained with the help of these two LDR sensors and that will be input to the microcontroller, and the south deviation will be achieved by this DC motor. So total 2 DC motors are used to place the solar panel always facing towards the sun, so that the system will get, means the solar cells will get the more sunlight on the solar cells and it will get the more power, and that will be given as input to this battery pack for charging purpose. So we are using 12 volts 1 amp DC battery pack, and also parallelly we are measuring the voltage of this solar panel and the battery voltage by using the PIC microcontroller, and that will be displayed on the 16:2 LCD screen. And also we can charge this battery pack whenever the sunlight is not available with the help of this transformer, means to the grid we can charge this battery pack. So for that, initially while we demonstration of the project, connect the S at this T by S slot, that will charging of the battery pack to the sunlight, and when the sunlight is not available, disconnect that and connect the transformer T at this slot as is shown here, then on the power supply to this transformer, so which will show the LED indication of the charging circuit, so that we can see the light indication when we are on the transformer. Okay, same thing, if you place this kit under the sunlight, same lighting will be, intensity will be present whenever we are getting the more lighting from the sun on the solar panel. Okay, so we should keep the battery under charge before demonstration of the project. It will take around 4 to 5 hours. Till the duration we should keep the battery under charging before demonstration of the project. So before the duration completion, if any battery fully charged, then automatically that charging circuit will block the current flow to protect the battery from overcharging. Now let us see the demonstration, and here we have interface, as we discussed, we have interfaced these 4 LDR sensors to the PIC microcontroller and the 2 DC motors to the microcontroller through this L298 motor driver, and which is used to control the direction of these DC motors whenever we are getting input from this LDR sensors. And this is a switch to utilize the power which was stored in the battery pack using these LEDs. So here this is a switch we are going to use to on the motherboard. Just we on this. So welcome message displayed on the LCD screen. So when we on that, this solar panel will be coming to the initial position. Consider this as the east side, and we are demonstrating that with the help of the lighting on the LDR sensors. And we can see solar panel available voltage as well as battery voltage is displaying on the LCD screen. So now it is east and west is moving. So in between, if there is any movement towards the south side, the solar panel getting the deviation with respect to that. So if I stop movement of this mobile phone, then the both LDRs will get the same light intensity, then it will stop movement of the solar panel movement by stopping the DC motor. Stops again. So once it reaches the west side limit switch, then it's indicated as day completed and sun was set, then it will come to the east side again. So once it touches the limit switch, then it will back to the east side. Again the south deviation motor also will rotate to make that in always east side, right. So for both sides we have kept the limit switch. This limit switch for south deviation and these two limit switches for east and west deviation. And coming to the utilization, directly we can just on this, we can utilize the power with the help of this LEDs by on and off. And just replacing the lighting on the solar panel, we'll getting the voltage. So 1 volt is getting, so when you place this on the full sunlight, you'll get the maximum voltage of 12 volts, right.